Good morning. I am Dr. Anitha DB, Associate Professor, CSE Data Science Department, ATME College of Engineering, Mysuru. Now I am going to demonstrate one of the ML Lab experiment. The statement is develop a program to implement principal component analysis for reducing the dimensionality of iris dataset from 4 features to 2 features. So here first thing we need to understand what is iris dataset. So this iris dataset contains 150 samples of 3 categories of iris flower and it has 4 features. So using that principal component analysis we have to reduce 4 features to 2 features and demonstrate that from 2 features only we can classify the iris data set into a particular type of the flower, and this is called as dimensionality reduction. So the first step is import the necessary libraries. So from sklearn.datasets import load underscore iris, that is load underscore iris. So from this we can get the iris data set which is available in sklearn.datasets. So then we need to import the principal component analysis algorithm, that is PCA, and this PCA is available in sklearn.decomposition. So the next one is standard scalar. So to perform the scaling operation for the original data value, we have to use the standard scalar because the principal component analysis works after scaling operation. So standard scalar is available in sklearn.preprocessing. Then pandas for handling data frame and matplotlib.pyplot. So in order to visualize the data. The next step, load the iris data set. So iris is equal to load underscore iris. So this iris data set has 2 parts. One is the data and another one is the target. So the data is nothing but 4 features, that is sepal length, sepal width, petal length and petal width. And the next data is the target. So the target is nothing but the type of the flower, that is setosa, versicolor and virginica. So using this data, that is we have stored iris.data in features and iris.target in target. So using this we can create one data frame. So iris underscore df is equal to pd.data frame of data is equal to features, that is sepal length, width, petal length and petal width. Then columns is equal to, we can give the name for the each column. So columns is nothing but the feature itself. So sepal length, sepal width, petal length and petal width. Then iris underscore df of target is equal to target. So target is nothing but, as I told, the name of the flowers, setosa, versicolor and virginica. Then iris underscore df dot head of, it will display the first 5 samples of the iris dataset data frame. If you see the first 5 samples, so it is having 4 features, that is sepal length, sepal width, petal width and the target. If we observe the target, so the target value for all 5 samples is 0. So 0 is nothing but setosa. 0 is nothing but setosa, 1 is nothing but versicolor and 2 is nothing but virginica. So totally this data set contains 150 samples. So first 50 samples are setosa, the next 50 samples are versicolor and the last 50 samples belongs to virginica. So that's why in first 5 samples we are getting target is equal to 0. So the next step, standardize the features. So here the features are nothing but sepal length, sepal width, petal length and the petal width. So perform the scaling operation on the feature. For that we can use standard scalar function. standard scalar of dot fit underscore transform of features and save it in another variable called as features underscore standardized. Now create a one more data frame based on the scaled features. So for that, let us consider the name of the data frame as iris underscore std, that is a short form for a features underscore standardized underscore df is equal to pd dot data frame. So to create a data frame, we have to use the function from the pandas, that is pd dot data frame, and we need to pass the input for the data frame, that is data is features underscore standardized. Instead of using features, here we are using the standardized feature, that is applying scaling operation on the original features, we got the standardized features. So data is equal to features underscore standardized. And name of the column, we are using the same name for the columns, that is sepal length, sepal width, petal length and petal width. Then iris underscore standard underscore df of target is equal to target. So add another column, that is the target column. So again display the first 5 rows. So this is the output of first 5 rows after performing the standardization. We can compare this with the previous first 5 samples. If we observe, these are the first 5 samples before performing the scaling operations. Next, after performing the scaling operation, so this is the output for the first 5 samples. Now we can apply the PCA to reduce from 4 features to 2 components. So apply PCA to reduce to 2 components. So PCA is equal to, PCA means this is a principal component analysis algorithm, and this can be implemented by using the function called as PCA. So for this we need to pass the number of components. How many components we need to consider for the outcome? So n underscore components is equal to 2. So from 4 features we are reducing it to only 2 components, that is principal component 1 and principal component 2. So now again apply PCA function on the standardized feature. So use the name of the variables to store this value as features underscore PCA equals PCA dot fit underscore transform of features underscore standardized. Now we are applying a PCA function on the standardized feature. Now once again create a data frame for the reduced data. Use the same pattern to create a data frame. So now use the name as PCA underscore DF. So this is nothing but the data frame after applying the PCA concept. So PCA underscore DF is equal to PD dot data frame. This is used to create a new data frame, and data is equal to features underscore PCA. Then columns, here we have only 2 columns, that is we are reducing 4 features to 2 components. So we are giving the name of the column as principal component 1 and principal component 2. So now adding another column for the data frame. So initially as per this line, the data frame contains only 2 columns, that is principal component 1 and principal component 2. Now for this add the target. So the target here, it is name of the flowers for the individual samples. So PC underscore DF of target is equal to target. Now print the output data frame, that is PCA underscore DF. So if you print this data frame, now if you observe, we are having 3 columns. First 2 columns are principal component 1 and principal component 2, and the third column is the target. So here principal component 1 and principal component 2. This data frame having only 2 features. So we are reducing 4 features, that is sepal length, sepal width, petal length and petal width, into only 2 components, that is principal component 1 and principal component 2. Here the target is 0. 0 means the setosa, here etc. and 2, it is nothing but virginica. So as I told earlier, the data set contains 150 rows, that is 150 samples, 50 for setosa, 50 for versicolor and 50 for virginica. So now visualize the outcome after the application of principal component analysis and check whether is it classifying the flowers into proper category. So visualize the result using plt.scatter. So this is the outcome. So even though from 4 features we are reduced to 2 component, we can easily classify the types of the flowers. So here red color indicates setosa, green color indicates versicolor and blue color indicates virginica. So we can identify what is the variance of the component. So principal component 1 having 0.72, that is 72% of the variance in the component, and principal component 2 contains 22% of variance. So total, if we add principal component 1 and principal component 2, around 95.8, that is 96% of the total variance is retained by using only 2 components. So this demonstrates that 96% of the variance in the original data set is retained in the reduced 2-dimensional data set. So we can use, instead of 4 features, we can use only 2 components. So this will reduce the time for the applications. Thank you.